So we are at the site of the Niobrara River sediment bedload collector pilot project. The project is funded by the Corps of Engineers Regional Sediment Management Program. The project is a collaboration between the Omaha District and the Engineer Research and Development Center, ERDIC, the Environmental Lab. I serve as one PI, and Chuck Thiling with the Environmental Lab is the other. The goal of this project is to really evaluate the sediment bedload collector technology and see if it has applications here on the Niobrara River, with the greater overview of looking at ways to manage sediment delivery from the Niobrara into Lewis and Clark Lake. So off to the right here, you see a couple of floating orange buoys. Below them is a sediment bedload collector. Is essentially a ramp with a grate inside it where the sediment that's bouncing along the bottom of the river falls into that grate, and we use a pump to extract that sediment from the river. There's a generator behind me. We are in a rural area, and so we're using the generator to power these pumps. And then once that sediment is out of the river, we're looking at evaluating how much sediment we're trapping, and then one of the follow-ons to this study will be how to beneficially use that sediment. So we're going to do some pumping and testing for about four days this week. And then when we wrap that up, we'll have a report on the efficacy of this system and how it might be implemented on the Niobrara River and many of the other tributaries in this reach. So Gavins Point Dam was closed in 1955 and was to full pool by 1957. Ever since that time, because the pool is very stable at Lewis and Clark Lake behind Gavins Point Dam, the sediment that's coming down the Missouri River and here down the Niobrara River is depositing in deltas above the dam. Through that process, the bed elevation has been continually rising throughout this reach. A number of issues caused by that. One is impacts local flooding. The same flow event might flood more than it used to. In addition to that, we're losing storage at Lewis and Clark Lake. And we are just west of Niobrara, Nebraska, where in the 1970s, the town was relocated from right near the river up onto the bluff because of raising groundwater levels due to the sedimentation in the lake. Our biggest challenge at this point is finding a beneficial use for that, finding a way to use it before it gets into Lewis and Clark Lake, or be able to remove it from Lewis and Clark Lake. We've been looking at a number of case studies where either a construction resource or a road maintenance resource could be a viable option. And so we are trying to find those opportunities, because at this point right now, moving the sediment would cost more than the benefits we would preserve at the Gavins Point project. And so our goal is to try and, if we can reduce the cost of harvesting and increase the benefit or the value of the sediment, we can kind of flip that paradigm and make it cost effective to move sediment. All right, so let's give you a short tour of the project site. We are up and running today. You see off to the right side here, where you see the two orange floats out in the river. That is the bedload collector. It extends 12 feet wide, and there are a set of pumps on this end of it. Think of it as a speed bump at the bottom of the river. It's kind of a ramp up. There's a graded area like a cow catcher, and then a ramp down. As sediment bounces along the bottom of the river, it falls into those grates. And then we use these pumps and these green hoses here to suck that sediment out of the bottom of that collector, and then we can take measurements on it, we can store it, we can pile it up for other uses, whatever the end use is for the sediment itself. So we have a control box here. These are variable speed pumps, and part of our testing is to determine whether the pump speed affects the collection. Whether we are supply limited or we are transport limited. Like, if we pump faster, do we have more sediment coming through? We'll find that out. That's part of the test here. We are running on a generator out here because no power out here. We're on the right bank of the Niobrara River, just west of Niobrara, Nebraska. Set of large tanks here that we use for collecting samples and determining flow rates and how much sediment per unit time we collect. We haven't hooked those up yet. What we're doing right now is we're running a line out to a geotube, which is a large synthetic bag where we can capture and filter sediment. So we'll go over there and look at that real quickly. If you see this green line going right here, this is the output. This is the line that's carrying the water and the sediment from the collector out here to the geotube and to our sampling station. Admittedly, it's a little swampy out here because, as you'll see here, we're trying to collect the sediment and then return the water to the river. And so this large synthetic bag right here, you can see this is a geotube. It's a mesh bag. These are oftentimes used for construction. The Corps of Engineers used them in 2006 or 7 to build emergent sandbar habitat below Gavin's Point Dam. Contractor took these bags, filled them with sand, and we created a large sandbar for tern and plover habitat in the shadow of the bag. So this is not a new technology to the Corps of Engineers. With the output here, we can either put it into this bag and collect the coarse material, or what we've been doing down here is putting essentially a filter sock on the end of the tube, and what that is doing is collecting this coarser material. This is what you all probably this is sand like from your sandbox that is collected. So this is that material that's bouncing along the bottom of the Niobrara River and is being pulled up by this bedload collector. What is not being captured in this process right now is the fines. They're very fine. What is known in this area as sugar sand. And this very fine sand material here, so it is so small that it gets through the pores of this geotube. So part of our sampling protocol is to, 1, sample the coarse material, which we collect in the bag here, and then 2, take some additional samples to measure how much of this material we're missing. Because this is still very valuable sand for whatever beneficial uses we have. And this is a significant part, a significant fraction of the total sand. So as we go through this process, we'll fill up some of these bags. We're looking at these different pump rates for efficiency. And then we'll go back and summarize our results into kind of an assessment of the effectiveness of this technology, specifically here on the Niobrara River, and then make some estimates on if we were to scale up this technology and apply it in more places in the watershed, what sort of impact could we have on the sediment deposition at Lewis and Clark Lake. In addition to that, so that we have a really good picture of what's going on in the area, we've partnered with the U.S. Geological Survey for them to take a bunch of samples in the area so we know what's coming by the sampler, and to be able to help us quantify the impact or the disturbance associated with the sampler. If we look over here real quickly, you can see that the USGS is collecting samples out in the river there. And the wire that's going out there to a sampler is to an optical sensor piece of equipment that's measuring the sediment below our bedload collector with the intent of attempting a general sediment budget and seeing if we can correlate that to how much sediment the collector is capturing. You can see over here we just turned this pump on. And this is the direct discharge from the collector. As you can see, just turned this on a minute ago. There's the sand fraction starting to come out there. And then all those fines that we talked about just a minute ago, they're coming out of here and returning into the river. So we'll sample this water to know how much of that fine. You can feel there's the grit of that fine sand in there. And then that'll allow us to take, this sand plus this sand to get the total amount of sediment we're working with. So we'll finish this project up in the next couple of days here, and then we'll work with ERDIC to publish a couple of reports on the applicability of the technology here on the Niobrara River.